Welcome to Chemistry World. In previous video, we have completed coordination compounds Werner's theory. According to Werner's theory, once again, just we go back. Today video, we will see previous problems, previous exams problems, and how we have to solve the problems from this theory. Easy way, simple steps we'll explain. So now first, in Werner's theory, every central atom has two types of valencies: primary valency, secondary valency. Primary valency is nothing but oxidation state of central atom. Secondary valency is nothing but coordination number of central atom or complex central atom coordination number. And coordination number nothing but number of dative bonds. Oxidation state means loss of electrons by the central atom. The primary valency is positive charged valency. That's why it is satisfied by negatively charged ions, and its valency is ionizable because it is satisfying by the ions. Generally ions are ionizable, so here it is ionizable. Now it do not contribute any shape. Why? Because the ions may be attached, or ions may be oppositely charged ions may attract each other from any direction. There is no directional for this bond. That's why these do not contribute. Primary valency never contribute any shape for the complex, and these are represented by dotted lines. Coming to secondary valency, it is satisfied by the ligands. Why? Because coordination number means what? Number of dative bonds. Dative bonds, another name is coordinate covalent bonds. So that coordinate covalent bonds is possible by the ligands. Why? Because ligands gives electron pairs. Already I told you, ligand means electron pair donor to the central atom. Central atom has empty orbitals that can accept the electron pairs which are coming from the ligands. By accepting electron pair, it forms dative bonds. So that ligands may be positive charge or negative charge or neutral molecules. Means primary valence is satisfied by only negative ions and it is ionizable. Secondary valence is satisfied by ligands that may be positively charged ions or negatively charged ions or neutral molecules, and this valency is non-ionizable. Once a coordinate covalent bond is formed, it never gives any ions, it is not ionizable, and it contributes shape. The shape of the molecule contributes, the shape of molecule depends on coordination number. Means secondary valency contribute shape of the molecule. That shape depends upon its coordination number. If coordination number 2 is there, the shape will be linear, and coordination number 3 is there, shape will be trigonal planar. Trigonal planar. If shape coordination number is 4, the shape will be maybe tetrahedral, or square planar, depending upon hybridization or orientation of ligands, approach of the ligands to the central atom, maybe tetrahedral or square planar. If coordination number 5 is there, the shape will be trigonal bipyramidal. And if the coordination number is 6, the shape will be octahedral. Like this. The shape is determined by coordination number. The coordination number nothing but secondary valency of central atom. This is Werner's theory. Primary valency, secondary valency, non-ionizable valency is secondary valency, ionizable valency is primary valency. This is the brief idea of Werner's theory. This is more than enough to solve the problems from Werner's theory. What are the problems? From simple board level to advanced level also, we can solve easily in simple steps. Let's come to the solution. How to solve the problems in a Werner's theory. So first thing, you have to listen the question, you have to read the question perfectly. Remember, students, one thing I am saying, you are understanding the question means you know the concept of the that question, or the topic concept you know. If you are not understanding the question means you don't know anything about the concept. So while you are reading that question, just get the idea, or understanding the question means you know the topic, you know the concepts of the topic. If you are not understanding the question means you don't know that. So before solving the question, whatever that is, first read the brief information and main information of the topic. Suppose If you have any question you want to solve in Werner's theory, so first you get the idea about the Werner's theory. Without getting any idea about the Werner's theory, don't solve the problems. And once again, from my experience, I am saying, don't observe the key, that is answer. While you're reading the question, what is the answer? Don't think about that one. First, what is the concept of the question? What is want to ask the concept from that question, you have to understand. First, understand the concept of the question. Automatically, you will get the answer. So, don't search for the answer while solving the problem. If you search the answer, you cannot get any answer properly. Competitive exam means, I'm saying to my students and also I'm saying to you, is not selection of the students. It is rejection of, and that is a less knowledge students. Those who have the more knowledge means those who have the concept, that students only will be selected in competitive examination. So competitive exam means selection of students based on the concept, not the selection of students based on the answers, not based on the buttifying. So not by hatting. So those who can, especially JEE mains, JEE advanced, NEET exam, the questions will become based on that concept only. How you are understanding the question and what you are thinking about that question, based on that question will be there. Not just like that, this is the question, this only the question will become next time, like that. Don't consider. One question will be rarely repeated in another paper, especially national wise exams. So let's go for the problems. The first problem and simple problem for Werner's theory is, I am taking from previous exams only. I am not taking from randomly. So first, let me get the previous problem. PYQ from Werner's theory. PYQ from Werner's theory, if you say, we'll get so many questions in Google, as well as we can get from anywhere also. But I'm taking the examples from previous questions only. PYQ from Werner's theory I'm taking. One question is there. COCl3 is treated with excess of HNO3. How many ions will be there? So let's go for one example. COCl3 dot 6NH3 is there. When it treated with the excess of AgNO3, excess of AgNO3, COCl3.6NH3 molecule is there. When it's treated with excess of AgNO3, it is giving 3 moles of AgCl as the precipitate. PPT means precipitate. So what is the structure of molecule and what is the exact formula of the molecule in us? So 3 moles of AgCl. What is the formula of complex? What is the formula of complex? This is the question will be there. I am writing the total question in short form. So when COCl6NH3 is there, when it's treated with excess of AgNO3, it is giving 3 moles of AgCl. So what will be the formula of the complex is there? Very, very simple. 3 moles of AgCl is coming means, please check the solution. 3 moles of AgCl forming means, 3 moles of AgCl is forming means 3 chloride ions are ionizable. 3 chloride ions are ionizable. 3 Cl minus ions are ionizable in the complex. Ionizable in the complex. If 3 chloride ions are ionizable in the complex, means if 3 chlorines are coming from the complex, then there is a chance of formation of 3 moles of AgCl. 3 chloride ions are ionizable means these are present in a primary valency. These are present in primary valency. Already I told in the theory, those ions which are present in primary valency are satisfying in primary valency, they are only ionizable. So 3 chloride ions are ionizable from this complex, means 3 chlorides are present in primary valency, means outside the coordination sphere these are present, means its coordination number is cobalt coordination number, that is secondary valency. Coordination number, we can also call it as secondary valency. It is constant for every central metal atom in the complex. So secondary valency, coordination number of secondary valency, that is 6, means 6 ligands are present in that complex. 6 ligands are present in that complex means, so they are 6 ligands are present inside the coordination sphere, 3 chlorines are present outside the sphere. So if I write 6 ligands, you can write the complex as CO, NS3, 6, 3 chlorines are outside. This is the formula of this complex based on the answer. This complex based on the answer. Once again I am saying, this is a complex he has given. Excess of AgNO3 when treated with, it is giving 3 moles of AgCl as the precipitate. PPT means what? Precipitate means. What is the formula of complex? If you say, you can see this one. 3 moles of AgCl forming means 3 chloride ions are ionizable from the complex. 3 chlorides ionizable means the 3 chlorides are present in primary valency. If they are present in primary valency, remaining 6 NH3 present in a secondary valency. Why? Because the coordination number of cobalt in this case is CO3 plus is the oxidation state, it is coordination number of CO3 plus is 6. So 6 NH3 present inside the coordination sphere, 3 chlorides are present outside the coordination sphere based on this concept. So the formula of this complex is CO NH36 Cl3. Like this you have to identify the answer. This is example 1 or problem 1. Simple problem. Suppose, if example 2, if I say, I think you have understood all these things. I am going to problem number 2. Problem number 2. Once again I am taking, this example was taken by Werner to explain the structure of complex compounds. So that only we are using, and in the examination also mostly the question will become from like this molecule or from this molecule itself, or like this any molecule you can take. Remember how many AgCls are coming from that. That only the main concept you have to consider. So now problem 2. Same COCl36NH3 molecule is there. When it treated with the excess of HNO3, is getting only 2 moles of AgCl, not 3 moles, 2 moles of AgCl as the precipitate is getting. 2 moles of AgCl. So what is the formula of complex? If it is there like that. Now let's go for the solution. 2 moles of AgCl forming means 2 chloride ions are ionizable in the complex. Sorry. 2 chloride ions are ionizable in the complex. Means 2 chloride ions are present in a primary valency. Means in coordination CO3 plus, the coordination number of cobalt 3 plus is 6, by because secondary valence is 6. So based on all these things, only 2 chlorides are present inside, means 1 chlorine is present inside. 2 chlorines are ionizable means 1 chlorine is non-ionizable, 2 chlorines only ionizable. 1 chlorine is non-ionizable means what? It is there in secondary valency. It is there in secondary valency. After that, you have to write square, you have to close the square bracket, means you have to close the coordination sphere. Then 2 chlorines you have to write outside. 1 NH3 is present as the ammoniated. Those ammonia which is there outside with this complex, that is called ammoniated, not coordinated. It is not giving electron pair. It is linked with this only by hydrogen bonds or whatever may be that, because that depends on ammoniated we can say. And here One chlorine is non-ionizable, so present inside. Two chlorines are ionizable. Why? Because we are getting 2 moles of AgCl. So this is the complex. CO, NH3 5, Cl, Cl2 dot NH3. Total 6 ammonia molecules. 3 chloride ions are there. Like this, you have to see the formula. You have to see the formula. And this is problem number 2. Once again, I am saying briefly. When COCl3 6NH3 is treated with excess amount of AgNO3, so we are getting 2 moles of AgCl as the precipitate means. What is the formula of complex? You may ask. If you are asking like this, so solution is please very simple and easy. 2 moles of AgCl forming means 2 chloride ions present in the complex are ionizable. 2 chloride ions are ionizable in the complex. Means the 2 chloride ionizables present in the primary valency. Why? Because those ions present only in primary valency, they are ionizable. Those present in secondary valency, non-ionizable. So here we are getting 2 chlorines, means the 2 chloride ions are present in primary valency. Then cobalt, in this complex cobalt coordination number is 6, means secondary valency is 6. So we need to write 6 ligands inside the complex. 1 chloride, if it is inside, only 5 ammonia is present as the ligands inside the complex. 5 chlorides only. Why? Because 1 chlorine is present already inside the complex and it is forming 1 dative bond. It is also acting as 1 ligand. So remaining 5 ligands we require. That's why I wrote 5. 1 more extra NH3 is present outside as ammoniated. Like this, the formula of the complex is CONH3 5 Cl coordination sphere close Cl2 dot NH3. Like this, problem number 2 will be there. And if example is problem number 3, if I take, when COCl3 6NH3 is treated with excess of AgNO3, when it is giving 1 mole of AgCl as the precipitate, 1 mole of AgCl as the precipitate, what is the formula of complex, you may ask. Suppose if you are asking like this, 1 mole of AgCl forming means 1 chloride ion is ionizable in the complex, means 1 chloride ion is present in the primary valency. CO2 plus coordination number is this. So then the formula becomes Cl2 inside, 1 chlorine is present outside. 1 chloride ion is present only in primary valency. They never present in secondary valency. So this, and the formula is Cl dot 2 NH3. 2 chlorides, 2 ammonias are ammoniated form and 4 ammonias acts as ligands. 2 chlorides present inside the sphere means they are linked with the central atom by dative bond. Only 1 chloride is ionizable. That's why we are getting only 1 mole of AgCl when treated with that complex. This is solutions solving based on that one. Suppose if you are getting 0 moles of AgCl, no chloride is ionizable. All chlorines will present inside. So the formula becomes CONH3 taken thrice Cl3, outside 3 NH3 will become. No chloride is ionizable if we are not getting any precipitate. So these are the problems to solve in a Werner series in very simple way. Based on Cl minus we have to take. This is some examples. Some more depth examples let's go for next video. Thank you.